This is homework 8, problem 15. And in this problem you're working with an exponential function. And it's about the decay of tritium. And we're going to be using our notes packet because we need the exponential equation word problem formula for exponential growth and decay. So we need this function that the function of time on something growing and decaying is the initial amount that you have of whatever it is times that funny number e, that exponential number, raised to the kt. Now I'd like you to rewrite that so you have room around it because we're going to label things. Okay? P is your starting amount or initial amount of whatever it is that you're analyzing. E is our exponential number. I don't need to label that because it's just a number. K is the rate of growth or decay. And it's given as a percent, and you've got to change it to a decimal in most problems. And T is the amount of time that this stuff, P, whatever that was, is growing or decaying. And A of T then is the result, the amount left, or the amount it's grown to. Now if you keep this in mind as we do this problem, it's fairly simple. So in letter A you're being asked what is this K value, this decay rate, and they tell you the percent is 5.6% in the information given. You know what? All you have to do, as I mentioned, is turn that number to a decimal. So we're turning 5.6% into a decimal. It means 5.6 out of 100. If it was 5%, you'd write 5/100ths, right? 0.05. But it's 5.6%, so we need to bring a 6 along in that next decimal place. Now if you don't understand that, just remember, percent is out of 100. That's a scrambled 100, that percent sign. So what you can do is type 5.6 in your calculator and divide it by 100. You can take any percent written as a percent, divide it by 100, and you'll have the decimal amount. Alright, that's going to need to be negative though. Think about why. In your packet here, they talk about if it's decay, K will be negative. K is going to need to be negative for decay and positive for something that's growing. So don't forget that negative sign. Alright, part B, we're supposed to write the function that we're going to need to use to solve problems about this tritium. And here it is. We just need to get stuff in the right place. Now we don't know what A of T is yet. We don't know the final amount. But we do know in letter B they tell us the initial amount is 10 milligrams, right? It says so right in letter B, 10 milligrams. So that's what we're starting with. We're going to multiply that amount by this funny number E, and we're going to raise that to the K times T. Well, we know what K is now. It's negative 0.056. We just don't know what T is. So that's going to be our unknown amount of time in the equation. In letter C, we're being asked, okay, it's been 10 years now that this tritium has been decaying. How much is going to be left? Well, we're going to need to find A of 10 years then. So on this side of the equation, I'm going to rewrite everything except where T was. I'm going to put 10. Now remember, this is all in exponents, so make sure you're writing it up high. And this is just plug and chug. I'm going to put all of this into my calculator on the right hand side of the equation. And it's not too tough to do. I type in 10 times e to the x. Remember, you should have an e to the x key on your calculator. And I've just typed mine in. Now my exponent is that negative 0.056 times 10, all in the parentheses that were behind my e. Make sure you've got that negative sign on there. That makes a huge, huge difference. And I end up getting 5.71 milligrams of tritium will be left after 10 years when we start with 10 milligrams. It's more than half of it left. Interesting.